Hello, you're welcome to our mathematics class. And in mathematics, we shall be looking at the topic statistics. This is a topic which we've broken down into three parts. In a part one, we shall be looking at pictorial presentation and frequency distribution. In statistics two, we shall be looking at measures of location. And in the third part, we shall be looking at measures of spread. First, what do we understand by statistics? It's a branch of applied mathematics that deals with collection, study, and analysis of numerical data. Data here has to do with information. Now, this data can be represented by the use of bar charts, pie charts, pictograms, and then frequency distribution. Frequency distribution can be represented by the use of histograms, frequency polygons, or we could have a frequency curve and cumulative frequency curve, which is also known as ogive. I will give a brief introduction to all this before we proceed into solving questions, since our focus is to solve questions. Take the first part, which is bar charts. A bar chart is a diagram that consists of vertical and horizontal bars whose heights or lengths are proportional to the frequency. We have a frequency here and we have a particular variable which we are to measure here, or a particular variable or a particular category which are given on this axis. Here we have the x-axis and here we have the y-axis. So this is basically what a bar chart looks like. Next, what about a pie chart? A pie chart is a circular chart with sectors which are marked with areas that represent the proportion of units in each of a set of given categories. And so from here, we could have several sectors of a particular category. For instance, transportation. We could have transportation, and under transportation, we have buses and the rest. So we could use each sector of this circle to represent each of the transport system. Next, a pictogram. A pictogram is a visual display of statistical information by means of pictures or drawings. So if you have to represent the number of cars or the number of vehicles that ply a particular road at a particular time, you would find that you will find cars, you will find motorcycles, you will find lorries and the rest. You can represent the information by drawing a diagram of this, all right? So that's what a pictogram is about. And next we move on to the frequency distribution representation. Now in frequency distribution, it is important to note that we make use of tables which are drawn, and then we will need what we know as the class limits. We have the lower class limits and we have the upper class limits. Likewise, we have what we know as the class boundary. We have the lower class boundary and the upper class boundary. We'll get to know more about that in a while. And then we have what we know as the class width. The class width is the distance between the upper class boundary and the lower class boundary. We have the midpoint of a class interval. And so an histogram is basically a graphical representation of a frequency distribution. When we talk about histogram, it is drawn such that there are no spaces between these rectangles that are drawn. They can be drawn by making use of their class boundaries. Also of note is that in histogram, we make use of what we know as the frequency density. The frequency density, which is the class frequency divided by the class width. We'll get to know more about this shortly. And then we have the frequency polygon, also from which we can get a frequency curve. Now a frequency polygon is one which is gotten by joining the midpoints of the tops of the rectangle from a histogram. So if we have a histogram, something like this. Now when we determine the midpoints here and we decide to join them, we join them in order to form a frequency polygon. We have 1, 2, 3, 4, 5. These are classes. Now if the number of classes are very much, we could just draw a curve to go around everything. And lastly, we talk about the cumulative frequency curve. In a cumulative frequency curve, which is also known as the ogive, is when we derive the sum of all the frequencies of the observation. So we have frequencies, and then which is plotted against a particular variable. When the graph of the frequency of the cumulative frequency, that is when the cumulative frequency is plotted against the upper class boundary, will form a cumulative frequency curve. And so now we proceed into solving questions under the first part of statistics. Here's the first question, which says the table shows the expenditure of a company in a certain year. We have a description: wages and salary of 25, fuel and power 15, raw materials 65, maintenance 5, miscellaneous 10. So all these have 1,000 attached to them. Now A, we have to draw a pie chart to illustrate the distribution of the company's expenditure. And B, what percentage of the total expenditure goes on fuel and power? Here, for us to solve this question, we're asked to draw a pie chart. And a pie chart is a circular chart with sectors. We are expected to have a circle. This is the center of the circle. And this circle, the sum of angles around the circle is 360 degrees. First, for us to represent all of this in a circle, we need to take the total of all this expenditure, and then we will convert it into degree. Here is how we get it done. And so we have sector angle over here. Let's add all this. When we add this, 25 plus 15 plus 65 plus 5 plus 10, that gives 120. To get the sector angle, we will have 25 over 120 multiplied by 360. That's how we get it converted into angle. Next, 15 over 120 multiplied by 360. 65 over 120 multiplied by 360. 5 over 120 multiplied by 360. 10 over 120 multiplied by 360. For the first one, for this we have 75. For this we have 45. Here we have degree. So all these are in degree. That's 360 degrees. All right. Then for the third one we have 195 degrees. For the fourth we have 15 degree, and for the miscellaneous we have 30 degree. All right. So we have just converted each of these expenditure into a sector angle. To confirm if it has been correctly converted, what we'll do is we add 75 plus 45 plus 195 plus 15 plus 30, and that will give a total of 360 degrees. Next, we want to represent this on this circle. Now this is best done with a protractor and a compass, also with a ruler. Now what we need to do, I normally prefer starting at a point. I'll have a ruler that will draw a straight line along this side, and from there I'll make use of the protractor, which is a semicircular object which is placed here to use to measure. So first 75 degree is measured. Then after the 75 degree we measure 45 degree. After 45 degree we measure 195 degree, and after 195 degree we measure 15 degree, and lastly we measure 30 degree. And so from here we'll label all the sectors. The first one we have wages and salary. Next we have fuel and power. Next we have raw materials. Next we have maintenance, and lastly we have miscellaneous. So when we take a look at this, it forms a pie chart. So that's how the pie chart is constructed. The B part says that what percentage of the total expenditure goes on fuel and power. When we take a close look at fuel and power, we have 15. We have 15 out of the entire 120,000 naira. So to get the percentage which was spent on fuel alone, we will have it as 15 over 120 multiplied by 100, since we have to find the percentage. And so this, when we multiply this out, we will have 12.5% is what goes to fuel and power. Next question says, a family budgeted the following amount on food items in a given month. Represent this on a bar chart. Alright, so we want to draw a bar chart of this information. We have rice 40 naira, meat 70 naira, oil 15 naira, vegetables 15 naira, beans 30 naira, yam 30 naira, fish 30 naira, and miscellaneous of 25 naira. To construct this, we have that a graph consists of vertical and horizontal bars. Here we can represent this as a food item bar. So we represent this as a food items bar, which is the horizontal or the x-axis, and over here we have our vertical axis. All right, so we represent this as amount, which is in naira. Here we have the 0 points. We have this as, let's call this 40 naira. We call this 60 naira, and we can have here as 70 naira. So we have 10 naira here, we have 30 naira here, we have 50 naira here, and we have here as 70 naira. First, we were told that 40 naira was budgeted for rice. So what we'll do is, using ruler, we will draw a vertical line and we'll represent this as rice. Next, we have meat. 70 naira was budgeted for meat, and so we will draw it until we get to 70. Here we have meat. Let's take note that we are expected to leave space in between each of the bars, and the space needs to be equal to each other. Next, we have oil. 15 naira was budgeted for oil, and so here is 0, here is 10. The midpoint here represents 15, and so we'll draw this down. We have this as oil. Next is vegetables, also 15. All right, so we'll draw this, and so here is 15. Next we have vegetables, which we also have as 15, as V. Next we have beans, which is 30 naira. Here is 30, so we'll trace it down here, and so we'll draw a line with a ruler that represents beans. Next we have yam, which is 35 naira. Over here we have 30, and so 35 will be the midpoint over here. So we'll draw it down. There it goes. We have yam. Next we have fish, which is 30 naira. Here we have 30, and so we'll draw 30 down, meaning that the same amount of money was budgeted for fish and beans, that is 30 naira each. And we have miscellaneous, which is necessary because of other things that may need to be bought. We have 20 here, we have 30 here, and the midpoint here is 25. And so we trace it down here, and so we draw a line down, and we have our 35. Here is a bar chart. Here is the bar chart. For clarity's sake, we're permitted to give a uniform shading of the bars. Here we have miscellaneous, MI. Some important points in this bar chart is that the spaces between the bars need to be uniform, and we need to label the horizontal axis as well as the vertical axis, and it needs to also have a title. Like this is a bar chart. This is a bar chart showing monthly family budgets on food, and it is ruled. Now it is not to be done in here, but above it, and then it is ruled. Here's the next question. It says the following table shows the frequency distribution of the masses. So the nearest kilogram of 26 children at a birthday party. Draw a bar chart to represent the distribution. Here we have the masses of 26 children. One child has a mass of 12 kilogram. One child has 13 kilogram. Two children each has 14 kilogram mass. 5 children each has 15 kilogram. 4 children each has 16 kilogram mass. 6 children Each of the 6 children has 17 kilogram. 3 children each has 18 kilogram. 1 child has 19 kilogram. Another child has 20 kilogram. And 2 children, each of them has 21 kilogram. Now this is a little bit different from the first bar chart we've drawn because we're given this. Now this represents frequency. We have 12 kilogram 1 as a frequency. 13 kilogram we have 1 child. 14 kilogram we have 2 children. And so we'll draw our graph, and on the horizontal axis the mass with its units, kilogram, and over here on the vertical axis we have number of children. Those are labeled on the vertical axis. For the 12 kilogram we have just 1 child, and so we'll place this here, 1 child. And then for 13 kilogram we have 1 child again. Now don't forget that we have spaces in between, and that space must be equal to the next space over here. 14 kilogram we have 2 children, so we trace this, we trace it. Next, 15 kilogram we have 5 children, so we have 5 children here, and we draw this up. Next, 16 kilogram 4 children, we have 6 children that are 17 kilogram, so we have 6 up here. Next, 18 kilogram we have 3 children, so we have 3 over here. 19 kilogram we have 1 child. 20 kilogram we have 1 child as well. And lastly, 2 children each has a mass of 21 kilogram, so we have 21 kilogram. Now we are permitted to shade the bars uniformly. Now here is a graph that shows the frequency distribution of masses of 26 children. So here is a bar chart showing frequency distribution of 26 children at a birthday party. And so this is the title of this bar chart. Here's the next question. It says the following table shows the vehicles passing a roundabout in 1 minute at Ipaja area of Lagos, Nigeria in a certain day. We have motorcycles 4 in number, cars 2 in number, van 3 in number. And then we have to illustrate the above information by a pictogram. We have that a pictogram is a visual representation of this statistical information, for instance. So we'll start by having motorcycles. Now we'll draw 4 motorcycles to represent this information. Alright, so we have 4 motorcycles, and next we're told that 2 cars, and next we're told that we have 3 vans. So for vans, alright, so here is a pictogram showing vehicles passing a roundabout in 1 minute at Ipaja area of Lagos, Nigeria in a certain day. Here's the next question. It says the following table shows the masses in kilogram of 50 students in a class. We have mass 31 to 40, 8 students, 41 to 50, 12 students, 51 to 60, 7, 61 to 70, 9 students, 71 to 80, 14 students. Find A, the lower class limits of the second class. B, the upper class limits of the third class. C, the lower class boundary of the fourth class. D, the class interval of the first class. E, the upper class boundary of the fifth class. F, the mid value of the fifth class. Before we go into solving this question, this is an example of a frequency distribution. Over here we have the frequency, we have classes, and in this frequency distribution we have a frequency table which summarizes the masses which we have now. And so this frequency distribution, we could have a group frequency distribution or an ungrouped one, and in this group we have classes of each group. For instance, we have several classes over here. So this is the first class, second, third class, fourth, fifth class. Alright, so we have the first class, second class, third class, fourth class, and the fifth class. Now these classes could either be discrete or continuous. So in this case, what we are having is they are discrete. And when we look at this, each of this class, for instance, this first class has 31. The 31 here is the lower class limits, and the 40 is the upper class limits of the first class. Here is the lower class limit of the second class, and here is the upper class limit. Here is the lower class limit, upper class, lower class limit, upper class limit, lower class limit, and upper class limits. Some other things we need to also take note of is that these classes can be adjusted. For instance, in our second class, we have 41 to 50. 41 is the lower class limit, and here we have the upper class limit. We could adjust it to 40.5 to 50.5, meaning that this 41 to 50 falls within these two boundaries, and so we'll call this the lower class boundary, and this is known as the upper class boundary of the second class. From here, we could determine the class width, also known as the class interval, and the class width or class interval can be gotten by subtracting the lower class limit, the lower class boundary from the upper class boundary. That is 50.5 minus 40.5, and we have 10 as the class width or the class interval. From here, we could also determine the midpoint of a class interval. And how do we determine the midpoint of a class interval? It's as simple as saying that the midpoint equal to the lower class boundary plus its upper class boundary, which is 50.5 divided by 2. And when we get this done, when we carry out this, we will be able to get the midpoint of the class interval. So with this information, we can easily solve these questions that follow. Alright, so we'll go into solving this question. First, we are asked to find the lower class limit of the second class. Here is the first class and here is the second class. And so the lower class limit of the second class, here is the lower class limit, which is 41. And so we have A equal to 41. B, we have to find the upper class limit of the third class. Here is the first class, second class, and third class. And this third class, the upper class limit is 60. So we have 60 over here. The C part says we should find the lower class boundary of the fourth class. Here is the first, second, third, and the fourth. So here is the fourth class. And in this fourth class, its lower class boundary can be gotten from its lower class limit. Its lower class limit is 61. And so to get this is the lower class limit. And so to get its lower class boundary, we will have it as 60.5. It's gotten by subtracting 0.5 from the lower class limit. Take note that the lower class boundary is lesser than the lower class limits. Likewise, the upper class boundary is higher than the upper class limits. It's important to take note of that. So here is the lower class boundary of the fourth class. This part of the question says we should find the class interval of the first class. Here is the first class. And so for us to find its class interval, we need to get its upper class boundary and its lower class boundary. Its upper class boundary will be gotten from the upper class limits, and that will be 40.5. And then its lower class boundary will be 30.5. So we subtract 0.5 from 31, we add 0.5 to 40. Alright, so 0.5 is added to 40. Alright, so we subtract this. When we subtract this, we have 0, 0, 1. And so here is the class interval of the first class. Next question says we should find the upper class boundary of the fifth class. Here is the fifth class. 1, 2, 3, 4, 5. The upper class boundary of the fifth class is gotten by adding 0.5 to its upper class limits, and that gives 80.5. So that is its upper class boundary. And F says we should find the mid value of the fifth class. Mid value of a class is gotten by knowing its upper class boundary and its lower class boundary. And so in this fifth class, its lower class boundary equal to 70.5 and its upper class boundary equal to 80.5. So with this information, we have that the midpoint equal to 70.5 plus 80.5 divided by 2. And so when we add this together and divide, we will have 75.5 as the mid value of the fifth class. Here's the next question. It says the weight to the nearest kilogram of a group of 50 students in a class in a technical school are given below. And so we have this table. A. Prepare a grouped frequency table with class intervals 45 to 49, 50 to 54, 55 to 59, etc. B. Find the mid value of the class interval 55 to 59. II. The frequency of the class 60. Okay, Roman figure 2. The frequency of the class 60 to 64. Roman figure 3. The class width of the least frequency. Roman figure 4. The class interval with the highest frequency. And Roman figure 5. Draw a histogram from the table. The first thing we need to do is to prepare a group frequency table, and we've been given the interval which we should make use of. Now in this question we shall be introducing histogram. Now first, we're told that we'll have classes. We have 45 to 49, 50 to 54, 55 to 59, 60 to 64, 65 to 69, 70 to 74. These are the class intervals. And when we look closely at these class intervals, they are uniform. That is, they are equal. The class intervals are equal. And so because they are equal, we can easily use them. Then next is that we'll look at the table of values that we're given. We will look closely. How many numbers fall from 45 to 49? We'll look at it. We'll take a count. How many 45 to 49 do we have? When you count it, you discover that you have 6 of them. So you place 6 against 45 to 49. Look at the table again. Numbers that fall from 50 to 54, we have 8 of them. And so we have 8. We place 8 against 50 to 54. Next, numbers from 55 to 59. When we look at it closely, we have 10 of them. So we have 10 slated against 55 to 59. And then from 60 to 64, numbers that are 60 to 64, we have 13 of them. We place 13 over here. And then from 55 to 69, we have 7. So we place 7 over here. From 40 to 74, we count them and we have 6. That is from the table. Now we are introducing a tally over here. Now for tally, when we have 6 here, we will have 6 is represented as 1, 2, 3, 4, 5, and 6. That's how we tally we tally the frequency. When you have 8, we count 1, 2, 3, 4, 5 is the stroke, 6, 7, 8. When you have 10, you have 1, 2, 3, 4, 5. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When you have 13, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. For 7, you have 1, 2, 3, 4, 5, 6, 7. And for 6, you have 1, 2, 3, 4, 5, and 6. The tally has been completed. So we have prepared a grouped frequency table. Here are the groups. Here we have to determine the mid value of the class interval 55 to 59. So the I part. To determine the mid value of the class interval 55 to 59, here it is. We will have to first, so this 55 is the lower class limit, and here is its lower, and here is its upper class limit. We need to determine its lower class boundary. The lower class boundary here is 54.5. That is, we subtract 0.5 from here, and then we add 0.5 to 59, and that will be 59.5. To get its midpoint, we would say that 59.5 plus 54.5 divided by 2, and that is more like looking for half of that, and half of that will give 57. And so the mid value of this third class is 7. Next is to find the frequency of the class 60 to 64. Here is 60 to 64. Its frequency is 13. So we have 13 written there. Roman figure 3. We have to find the class width of the least frequency. The least frequency here, we have 2 least frequencies. We have 6 and 6 here. So the first 6, it belongs to 45 to 49. And the second belongs to 70 to 74. And so to get the class width, which is known as the class interval, what we need to do is, here is its upper class limit and here is the lower class limit. Upper class limit and lower class limit. So we need to get its upper class boundary, which is 49.5, minus its lower class boundary, which is 44.5. We subtract it, and then for this as well, 74.5, which is its upper class boundary, minus its lower class boundary, that is 69.5. When we subtract this, we have 5, and for this we have 5, and so these are the class widths. The next question says we should determine the class interval with the highest frequency. Here is the highest frequency, 13, and so the class interval is 60 to 64. Roman figure 5 says we should draw a histogram from the table. Now, to draw a histogram from this table, first we need to watch that the class intervals are equal. So in this case, the class intervals are equal. They have 5 as a difference between all of them. We have to plot this frequency against the lower class boundary. But if the class intervals are not equal, we will need to determine what we know as the frequency density, which is equal to class frequency over class width. We shall go there in a while. For us to draw a histogram, we have this. Now we have to plot the weight in kilogram against the frequency. Next, we need to determine some things, like this first class, its lower class boundary is 44.5. The lower class boundary of this next one is 49.5. Here we have 54.5. Here we use 59.5. Here we have 64.5, and here we have 69.5. These are the lower class boundaries. Next, we have the upper class boundaries. The upper class boundaries for here is 49.5. You will take note that the upper class boundary, where this one is ending, is where this is starting from. Likewise, this 54.5, and then 59.5, 64.5, 69.5, and 74.5. With this information, we won't have any space between the rectangles of this histogram, and that is what is done. That is how it is done. Unlike in bar graph where there's space, and the space is because of we are not plotting with the class boundaries. Now that we are plotting with the upper and the lower class boundaries, here's how we get it done. And so the first one, from 44.5 to 49.5, and so we'll have the first one here to be 44.5. Now we would have our frequency stated here. We'll have 2, 4, 6, 8, 10, 12, and 14 on the frequency column. Next, for 44.5 to 49.5, all right, 49.5, we have 6. We'll draw it up to 6, and so here we have 49.5. Next, from 49.5 to 54.5, we have 8, and so we'll draw the next line, and so here is our 54.5 for the second class. For the third class, from 54.5 to 59.5, which is 10, and so we'll move up, and so here we have 59.5. Next, from 59.5 to 64.5, we have 13. Here we have 13 up here, so it moves up, and so here is 64.5. Next, we have 69.5, which is 7. Here is 6, 7. Here is the midpoint, so we trace it down here, and we draw this, and so we have 69.5 here. And lastly, we have 6, which is for 69.5 to 74.5. That is 6. So we have 6 here. Then we trace it down here, and so here we have 74.5. So from what we have here, we have successfully drawn a histogram showing the weight to the nearest kilogram of a group of 50 students in a class in a college of technology. Here is the histogram. Draw a frequency polygon from this particular histogram. Now, to draw a frequency polygon from this histogram, what we need to do is to find the middle of these rectangles. We connect the middle using your ruler. You connect it, and here it goes. So this is a frequency polygon which can be drawn from a histogram. So we have a next question. It says the following table shows the masses of 50 athletes who reported for an athletic competition. So here is the table, and A, we have to use the table to construct a histogram. B, draw a frequency polygon from the histogram constructed. Here we have a table. We have the mass in kilogram. We have 41 to 50 kilogram. We have 8 people within this mass class. 51 to 70, we have 12 people within this mass class. We have 71 to 80 kilogram, we have 10 people. 81 to 100 kilogram, we have 14 people. From 101 to 110 kilogram, we have 6 people. When we take a close look at this table, here 41 to 50, there is a class interval. The class interval here is 10. That is from 41 to 50. That is a class interval of 10. From 51 to 70, the class interval has changed, and over here we have 20. From 71 to 80, we have 10 as the class interval. From 81 to 100, we have 20. From 101 to 110, we have 10. And so we have unequal class intervals. And it may not be possible for us to construct a histogram using the frequency against this mass or this class interval. And so what we need to do is that we are going to derive a frequency density. And so instead of us using frequency on the y-axis, we will not use frequency, rather we'll use the frequency density. And here is how we go about it. First, we construct another table. Here we have 41 to 50 kilogram. This is the first class interval. Here is the second class interval, third, fourth, and fifth class interval. Then we need to determine the class width. How do we determine the class width? We determine the class width from knowing the lower class boundary and the upper class boundary, and then we subtract it. And so when we subtract it, we have 10 over here. For this we have 20. For this we have 10. This we have 20, and here we have 10. So these are the class widths which we make use of. Next, the frequency. From 41 to 50, we have 8 people. From 51 to 70, we have 12 athletes. From 71 to 80, we have 10 athletes. From 81 to 100, we have 10 athletes. Okay. From 81 to 100, we have 14 athletes. From 101 to 110, we have 6 athletes. Next is to get the frequency density. Frequency density equal to the class frequency over the class width. So for the first one, the class frequency is 8 over the class width, which is 10. And so 8 divided by 10, that gives 0.8. The next one is 12 divided by 20, and that leaves us with 0.6. Next is 10 divided by 10, we have 1.0. For the next, 14 divided by 20, we have 0.7. And 6 divided by 10, we have 0.6. Next, we'll draw the histogram. Alright, on the x-axis, we will have the mass, which is in kilogram, and then on the y-axis, we have the frequency density. So for the mass, what we will use to construct this histogram is not going to be this class interval. We are going to make use of the lower class boundary and the upper class boundary. Over here, the lower class boundary is 40.5 and its upper class boundary is 50.5. Over here we have 50.5, and here we have 70.5. Over here we have 70.5, and here we have 80.5. Here we have 80.5 to 100.5. Over here we have 100.5 to 110.5. Those are the lower and upper class boundaries. Then for the frequency, we have from 0.6 to 1, and so we could vary it. Alright, so we have 0.1 here, we have 0.1 here, 0.3 here, 0.5 here, we have 0.7, we have 0.9, and we have 1.0. And so here we have the frequency density. So the first one we have is 41 to 40. So we take it as we have the first one we have is 40.5. And so we have 40.5. The next we have 50.5. We're going to have all the class intervals as possible, like this. We have 60.5, 70.5, 80.5, 90.5, 100.5, and 110.5. So from 40.5 to 50.5, it has a class width of 10. Next, 40.5 to 50.5 has a density of 0.8, and so we'll trace it to, here is 0.8 here, so we'll draw this, we'll draw it down. Next, we have 50.5 to 70.5, here is 50.5 to 70.5, that's 0.6, and so here is 0.5, here is 0.6, so we'll draw it down here, and then we'll trace it down. Alright, so we'll trace this down. Next, 70.5 to 80.5, here is 70.5 to 80.5, and that is 1.0, and so we trace that up, then it goes down. Next, from 80.5 to 100.5, here is 100.5, so 80.5 to 100.5, we have 0.7, so here is 0.7, so we'll trace it over like this. Next, 100.5 to 110.5, we have 0.6, this is 0.5, here is 0.6, so we have 0.6 over here. Now I believe that using a good graph, you get something neater than this. We have just constructed a histogram for this table by making use of the frequency density and its class boundaries. Then the B part says we should draw a frequency polygon. And so to have a frequency polygon for this, we just need to connect the midpoints of each of them, and then we go 1, 2, 3, 4. Here is the frequency polygon, which was drawn from the histogram. Next question says, the following table shows the length of 50 aluminium rods in an aluminium window manufacturing company. Here is the table. We have to construct for the distribution A cumulative frequency table, and B, a cumulative frequency curve, which is also known as ogive. Now, for us to get this done, we have the length of the aluminium rod from 30 to 39, we have 5 of them. From 40 to 49 centimeter, we have 8 of them. From 50 to 59, we have 15 of them. From 60 to 69, we have 12 of them. From 70 to 79, we have 10 of them. All these have equal class intervals. And then, when we add all this, we will arrive at 50. First, we need to get a cumulative frequency table. The frequency table is constructed like this. We have the length. When we want to construct this, now we have the length and we make use of the class boundaries. And so when we take a look at this, 29.5 is the lower class boundary of the first class. So we have that. The cumulative frequency of that, we'll take it as 0. Then from 29.5 to 39.5, here we have 5. And so not exceeding 29.5 is the first length. Not exceeding means that not less than this. So anything less than this, we have 0 of it. That means there is no aluminium rod that is less than 29.5 according to what we have here. And then from 29.5 to 39.5, we have 5. From 39.5 to 49.5, here we have 8. And so the cumulative frequency will be 5 plus 8, which is 13. And then from 49.5 to 59.5, that is from 49.5 to 59.5, we have 15. And so the cumulative will be this 13 plus 15, and that gives 28. Next, from 59.5 to 69.5, which is this 59.5 to 69.5, we have 12. And so the cumulative will be this 28 plus 12, that gives 40. And then from 69.5 to 79.5, which is here, we have 10. Now the cumulative will be this 40 plus 10, and that is 50. And so that is more like saying, here is a 5, 5 plus 8, 13, 5 plus 8 plus 15 gives this, 5 plus 8 plus 12 plus 12, plus 15 plus 12 gives 40, and then when you add everything, it gives you this. And so the title of this table is the cumulative frequency table showing length of 50 aluminium rods. That is the title of this table. And next, we'll construct a cumulative frequency curve. A cumulative frequency curve is a graph of the cumulative frequency versus the upper class boundary. So we are going to make use of the upper class boundary. And so we have over here, we have the cumulative frequency, and here we have the length in centimeter. This point here is 0, and that is 29.5. And after 29.5, the first upper class boundary is 39.5. So we have 39.5. After that we have 49.5. After that we have 59.5. We have 69.5. We have 79.5. The next is for us to point to locate our points on the graph. 29.5 and cumulative frequency of 0. Alright, so then we will need to make our plot on the y-axis. Alright, so we can move like this: 10, 20, 30, 40, and 50. For the first part, when we have 29.5 with 0, which is this point. Next, 39.5 and then 5. Here is 39.5 and we locate 5. So when we use a proper graph, we will point to it accurately. Then 49.5 stroke 13. Here is 49.5 and we have 13. 13 will be just after 10. Next, 59.5 and 28. So here is 59.5 and then we'll trace to where 28 will be. So here is 30. Just before 30 we have 28, and then that is 28. Next is 69.5 and 40. Here is 69.5 and then we need to locate 40. Here is 40, so 40 goes here and then to 69.5. And next we have 79.5 and 50. Here is 50 and 79.5. Down we have this. We have our point. Next is we will use a ruler to join it. So this is a cumulative frequency curve or ogive showing length of 50 aluminum rods. So here's the next question. The pie chart below illustrates the amount of private time a student spent in a week studying various subjects. A. Using the chart, find the value of K. And B. If he spends 2.5 hours a week on science, find the total number of hours he studies in a week. Alright, so here is a pie chart where we have mathematics 105 degrees, science is 75 degrees, then 3K is for English, that's in 3 times K, and then we have K for others, and then 2K for social studies. We have to find the value of K, and we know that the sum of angles at a point in a circle equals to 360. And so what we need to do is to add all this and equate it to 360. And so we have 105 plus 75 degree plus 3K plus K plus 2K equal to 360 degrees. 105 plus 75 gives 180 degree. 3K plus K, that's 4K. 4K plus 2K, that's 6K. So 6K equal to 360 degrees. 6K, we collect like terms. 6K equal to 360 minus 180, and that is 180. Hence, K equal to 180 divided by 6. So we have 30 degrees. Hence, the value of K is 30 degrees. The second part of the question says that if he spends 2.5 hours a week on science, what we have here is that 75 degrees out of 360 is used. So we're now told that if you use 2.5 hours, meaning that we are going to equate this to 2.5 hours. So how many hours does he spend in all? What does that mean is if we say that 2.5 hours is equivalent to 75 degrees, how many hours is this 360 equivalent to? And so we have x hours equal to 360 degrees. We cross multiply and we have that 75 multiplies x equal to 2.5 multiplies 360. And so we have that x equal to 2.5 is 5 over 2 times 360. And then this 75 will come down. We have 75 here. And so when we cut this, we will have 12 hours. And so what we are saying now is that these students use these 12 hours in a week to study.